In last video we discussed about interference, and we also got the conditions for constructive and destructive interference. We know that constructive interference means it results bright fringes, and destructive interference means it results dark fringes. Okay, now in this video we are discussing Young's double slit experiment, or in short we call it YDSE. Okay, now see, in this Young's double slit experiment, this is the experimental setup. Two slits are taken, slits S1. Slit means just like in camera we have that slit, so in the same way, very small, the slit of very small width we have taken S1. This is another slit S2. Okay, now for these two slits we have a source somewhere here. Excuse me. So from this source, from this single source, light waves will generate like this. Okay, this is wavefront. This wavefront will fall on this slit, and since this part, it has only two holes, S1 and S2 are considered as the slit, so we will get light waves moving in two different, or from two different sources. These two S1 and S2 will be called as a secondary source of light. Okay, the primary source is S only. Alright, now why this is done? Because so that from a single source we can get two sources of light. The reason is that we want to take here monochromatic light. Monochromatic light means the light rays having the same wavelength. Okay, same frequency or wavelength, monochromatic. And these two sources which are you can say originating the monochromatic light, these two sources are known as coherent sources. Okay, now though it is a wave, because in this chapter we are discussing waves, but since it is difficult to draw the waves, or the diagram will be not much clean, so that is why we draw it in the form of rays. Okay, like this. This is one ray, this is another wave, both are meeting at point P, suppose. Now in this figure, see here the thing is very theoretical and you have to understand this part. Okay, suppose we consider that this is one wave, this is another wave meeting at point P, but is it necessary that these 2 points S1 and S2 will produce only two waves? Not necessary, right? It may produce some waves, or some wave which is directly moving to point C. C is the central point we call. From S2 also another wave can directly reach to point C. Now see, these two rays, when they are meeting at point C, they are traveling equal distances, because S1C and S2C is equal. Once they are traveling equal distance, they don't have any phase or path difference. Path difference in last class we discussed, delta x. Since they are moving same distance, path difference is equal to, there is no path difference, or we can say that path difference is equal to 0. Now what is the meaning of it? Path difference equals to 0. That means if, okay, suppose this is a wave which is suppose S1C, another wave. Now if they don't have any path difference, then at point C either the trough of both the waves will meet, or the crest of both the waves will meet. And if it is so, the intensity of point C will never be 0, because if it is crest, it has a value, the value is a positive value. If it is trough, it has a value, the value is negative value. If suppose this is amplitude, okay, now suppose if the first wave, that means S1C, it has an amplitude of +5, crest is having an amplitude of +5, trough will have an amplitude of -5. Okay, similarly another wave, that is S2C, it also has same amplitude, suppose almost +5 for crest, -5 for trough. Now from both the waves, if the crest is meeting at point C, what will be the total intensity of point C? Crest is meeting, +5 from one wave, +5 from another wave, resultant is 10. So 10 is not equal to 0, right? If it is 0, then this point will be a dark one. If it is non-zero, plus or minus, this point will be a bright one. So suppose when two crests are meeting at point this, the resultant will be 10. If two troughs are meeting, the resultant will be -5 -5, that means what? -10. -10 is not 0, right? So it has some intensity, and if it has some intensity, point C will be a bright point. Again I am telling what I said. Since S1C, this wave, and S2C are having no phase difference or path difference because they are traveling equal distance, so if the crest of this wave falls at C, the crest of the another wave will also fall at C. So crest plus crest will give us some positive value, non-zero value. If the trough of this wave falls in C, the trough of this wave will also fall on C. So the answer, so value will be -5 -5, means it is -10 but not 0. So point C will be in any way a bright point. But yes, if the crest of one wave, suppose for an example, if the crest of one wave is how much? +5, meet with the trough of one wave which is -5, resultant intensity will be 0. And this thing will happen only and only if they have a phase or path difference. But in this case, when it is reaching to C, they don't have any path difference. They are traveling equal distance. I hope it is clear. So point C, in any way, point C will be a bright point. We call it the central bright fringe. Okay. Now in this figure, generally our focus is on these two waves which is originating from S1 to P. Another wave is originating and reaching to P again. What will happen to these two waves? Now see, S2P wave, it has travelled more distance as compared to S1P. So there is a path difference. How much is that path difference? If you draw one perpendicular like this, just a second. Okay. Yes, if you draw one perpendicular like this, then this length RP becomes equal to almost S1P. So this is the extra length S2R, which is suffered or which is moved by S2P wave. This is the extra length. So can we say this is the path difference? This is the path difference, means delta x. So what is the value of delta x here? S2R. And if they have path difference, there is a possibility that at point P they may meet crest to crest, they may meet trough to trough, they may meet crest to trough also. So that means point P can be a bright one or a dark one. It depends on certain condition. So we will find out under which condition point P is a dark one and under which condition point P is a bright one. Okay. Now first let us explain the figure. Okay. Here these two slits, they are separated by a distance d. D is a very small distance in the order of few millimeter. This is the screen, this one. Okay. The screen is separated from the slit by how much distance? Capital D. This capital D is in meter in most of the cases. This is the central bright fringe. From central bright fringe, the point P is at a distance of y. Okay. Then this is a line which is giving us the angle made by point P or made by this line with the central maximum or with the central line. This is the central line. This is the line joining point P from the center of the slit, and this is the angle theta. Okay, fine. Now as I already told you, S2R is the path difference. So now let us see, we will find out this path difference S2R. certain assumptions we have to consider here. Okay, I have written here S to R is delta x, means there is a path difference, and this S to R is nothing but path difference, right? So path difference means what? S to P, I mean the larger path, minus S1P, right? So that's what I have written, S2P minus S1P. Now from triangle S1PA, S1PA, this triangle. So in this triangle, hypotenuse is S1P. We can use Pythagoras theorem. S1P is equals to S1A square, this one, and AP square. Now S1A is nothing but capital D. So S1A square means capital D square plus AP. AP means which part? This part. Okay. So if AP is this part, can we write it like this? Y, just a second, AP, right? AP means can we write Y minus AC? See the figure, Y minus AC. Now this AC means this part, half of the slit width. Half of the slit width, the separation between two slit is D. Half of the slit width means it will be D by 2. So AP is nothing but Y minus D by 2. You just see the geometry, things will be clear to you. Okay. So Y minus D by 2 whole square. This is given equation number 1. The thing is that this one, no, AC. This AC is equal to what? D by 2, half of small d, no? And similarly, this CB. CB is also half of D, half of small d. Right? Now, again we have taken another triangle, S2PB. In this triangle, hypotenuse is S2P. So, we will write S2P square. Base is this one, that is S2B square. S2B square, and this one is BP. So BP square. Now this BP is nothing but Y plus small d by 2. So we'll write here Y plus d by 2 whole square. This is given equation number 2. Okay. Then we will subtract 2 minus 1. Okay. Once we do so, see in left hand side what we are getting, S2P square minus S1P square. This capital D square get cancelled. We get this one. You just open the bracket. A plus B whole square formula, apply it. That is just simplification. Certain terms will get cancelled like y square, then this one and this one. Yd plus yd gives us 2yd. Now see in left hand side, this is in the form a square minus b square. We can use a plus b into a minus b formula. There is some approximation, because I told you that this separation D is very less, it is in the order of few millimeter. So in that way we can just assume, okay, not here, not in this case, because this is the path difference, S2P minus S1P, this one, delta x. So here we are not using the approximation, we will keep it like delta x. Approximation we are using here. What kind of approximation? Suppose since this distance is very small as compared to this D, it is in millimeter, it is in meter, okay. So that is why what we do is, we just consider S1P is nearly equal to S2P is nearly equal to capital D. Just assumption, and this assumption we will use only here. If we do so, if S1P, S2P both are equal to capital D, so this will be what? 2D, D plus D, 2D, this one, okay. So from this 2 get cancelled, this one and this one, we are getting delta x equals to yd by d. What is delta x? Path difference between these two, okay. Now the condition is that this point P will be a bright one if this path difference is equal to, what was the condition? In last class I told you, okay. Let's see that, this one, path difference, if the path difference is n lambda, then it is a constructive interference, or we get bright fringe. You got this condition in last class, okay. N starts from 0. So delta x means what? Yd by d, just now we got, or from this y is equal to n lambda d by d. So if where n starts from 0, right? Okay, see here, if we substitute n equals to 0, y becomes 0. So when y is 0, that will be a bright fringe. This is the first bright fringe. Now which one is the bright fringe for y equal to 0? Y equal to 0 means which bright fringe? This one, you see. Y means it starts from center C, center C to P. Now if y is 0, that means this P point is nowhere but at C. Okay, so C is a bright point. We already know C is a bright point. Already I told you that if this is moving to C, this is moving to C, they don't have any path reference, and point C is a bright one. So that's what we got here also. Clear? Next, for n equal to 1, y will be lambda d by d. So that means when this distance y from this C is lambda d by d, just a second, lambda capital, when n equal to 1, this will be lambda d by d y, right? So when y means this distance from center becomes this value, then in that position we are going to get the next bright fringe. For n equal to 2, there will be 2 lambda d by d. In that position also we are going to get the next bright fringe. For n equal to 3, there will be 3. We are getting the next bright fringe. So in that way we are getting the bright fringes according to this formula. Okay, y means when n is 0, that is the central bright, n1 first bright, n2 second bright, like that it goes on. Okay, now point P is a dark one, or we get destructive interference or dark fringe. Under which what condition? This was the condition, you remember that. You already got this, right? N starts from 1, 1, 2, like that. So delta x, substitute the value that we got just now. Simplify, we get y equal to this. Okay, so this is the condition for dark fringe. So at what length we are going to get the first dark? Substitute n equal to 1 here. If you do so, this will be how much? 2 minus 1 means 1. So y becomes, for n equal to 1, y is nothing but lambda d by 2d. So at this length we are going to get the first dark. Second dark, where we are supposed to get? Substitute n equal to 2. 2 2s are 4 minus 1 3. So that means 3 lambda d by 2d is equal to y. At this position from the central maximum we are going to get the second dark fringe. In that way it goes on. Okay, I hope it is clear. And yes, the fringe, the pattern is like this. Just a second. Okay, the pattern comes like this, though it is, I have not shaded this region, you'll understand, right? This C means it is the central bright, this part is the central bright one, this gap. Okay, after that this shaded part, this part is the dark one, first dark, then next bright, this part, next dark, this shaded one is the dark one. Okay, so in that way we get the interference pattern. This is the pattern. Next topic will be fringe width. Okay, fringe width, for that I will make another video. Alright, thank you.